Alright, boys and girls, welcome back to the drive-through for an extended ACE version. Sponsored by the deli. Hungry? Stop by the deli and make yourself some lentil tacos, if you wish. Alright, hey, this is to help you with your 2.6 to 2.8 guided notes. Most of you did this with me today in class, but if you weren't here or if you just didn't get it the first time around, I wanted to make a video to help you out. So I'll try to go as fast as I can so I don't waste your time. Feel free to pause or rewatch the video if I do anything too fast. What we're really trying to figure out is what happens to these graphs when we change the equation. Okay? So I'll start by graphing these four things on my graphing utility, which is over here. So x squared looks like that. So that's a parabola whose vertex is right here at the origin. If we write it as x squared minus 3 as in equation in B, you can see that the blue parabola goes with this equation and that our parabola has been shifted down 3 units. Okay? If we called it x minus 3, or actually it's minus 5, in parentheses and then squared it, notice that that has moved it 5 units to the right. And if we called it 4 times x squared, notice that that purple one is what we would consider thinner, or it's getting bigger faster than the red one. So that brings us to filling in this sheet, okay? And we're under translation, you could simply write a shift vertically or horizontally. Under reflection, you could write a flip. Okay? The parent function, you don't really need to write anything for my class. Okay, so an example of a vertical translation is y equals x squared minus 3. This would be down 3. Okay? An example of a horizontal translation would be y equals x minus 5 in parentheses squared. Now, anytime you have something in parentheses, the result is what I call counterintuitive. You would think that the minus 5 would make it go left 5, but it doesn't. It's actually right 5. So be careful inside of grouping brackets or even absolute value. The result is counterintuitive. Okay? An example of a vertical stretch would be y equals 4x squared. That is 4 times, and what I'll call thinner. Some people say that that's stretched vertically. Okay, and then if you had y equals negative 4x squared, this would be flipped upside down, and it's also thin. Okay? Alright, I have no idea what just happened there. I was trying to pause it and it didn't work. So let's try to. Okay, so as we scroll down, maybe you recognize that this is going to result in a translation going down 1 unit. This one is going to go up 7 and right 3. Remember, this controls the up and down. Inside controls the left and the right, but it's counterintuitive. Okay, this one is going to be down 4, left 5, and flipped. And it's flipped from that negative sign right there. Okay? This is the same thing down here, but now instead of the same parent function every time, it's saying this is the parent function. Describe what happened to it below. So this one would be flipped from the negative sign. Okay? And since this is a grouping symbol, the absolute values, it's going to be counterintuitive. It's going to be left 6. Okay? This one is going to be down 4 because there are no parentheses there. So down 4, and then, I don't know, less steep or flatter by 1/3. Don't sweat that too much. Again, here's our parent function. So this is going to make it go up 1, and this is going to make it go left 2. Okay, so now we've scrolled down even further. Hopefully you can figure out how to use the absolute value feature on your graphing device, but if not, you should Google that. We did that during class, but you'll find that the general absolute value graph looks like a V. Okay? So, just like before, this is counterintuitive. So this is going to make it go right 4. And it's going to look like that. Here, the vertex is 0, 0. Here, the vertex is 0, 4. Okay? All right, well, this one's going to make it go up 2 and down 2 and left 3. So down 2, left 3. Our vertex is now -3, 2. And the graph looks exactly the same. It's got the same slope, and it's got that same V formation. Okay? Thank you. Always looking out for me, Val. Shout out to Val, old school deli member, now an assistant coach here at the deli. All right, so this one is going to flip upside down, and it's going to be twice as steep. Okay, and so you can't see back there, but the vertex would be 0, 0. Uh-oh, this is where I got messed up last time. Nope. Okay, and finally for the last section, this is just your shading rules for inequalities. So if it's both of them are less than, then we would say shade below. Okay? If both of them are greater than, then we shade above. Okay? If it's greater than or less than with the number in the middle, this would be like shade in between. So we would shade in between them. And, well, I guess I shouldn't just put it that. This one would be dotted. I should have dotted those. And this one would be look like that. But that's not going to help you a whole lot, but that'll help you fill in your notes. We'll go into the examples here, and it'll get you started. So treat this to start like it's an equal sign. So this thing is usually a line. It's a line with a y-intercept of 4 and a slope of negative 1/3. So we start by graphing a line. Since it's less than, then we dash that line. If it was less than or equal to, then that line would be filled in. Okay, and then since it's less than, we will shade below it. I always test a point when I'm done to make sure that I did it right, and I test the easiest point that I can. So for example, this point here should work because it's in the shaded area. So is 0 less than 0 plus 4? Yes, it is. 0 is less than 4, so that works, okay? Here, you guys might have a little confusion on how to graph that line. Consider this line to be x minus 2y equals 8. Well, I would choose to put in the intercepts for this one. So if you put in an 8 for x, you get a 0 for y. And if you put in a 0 for x, you get negative 2y equals 8. You get a negative 4 for y. This is less than or equal to, so this line will be filled in. All right, now, in this form, it's hard to make a determination, so you want to write it as negative 2y is less than or equal to 8 minus x. Divide everything by negative 2. We have to switch that sign. You get that it's in that form. So that means we are going to go above it. Now, since I had to switch the sign, I'm not completely convinced that I'm right. So I'm going to test this point 0, 0. Is 0 less than 8? Yes. So that's how I'm confident that I did it right. Okay, so again, consider this y equals the absolute value of x plus 3. This is going to be a left shift. I would hope that if you were confused, you would just put this in your calculator. Okay, now y is greater than x plus 3. So that tends to mean above, so I think the answer is going to look like that. Okay, however, I should test. Now this point 0, 0 should not work. Is 0 bigger than 0 plus 3? Is 0 bigger than 3? It is not. This point should work, the point 5 comma 0. Is 0 bigger, 0 comma 5. Is 5 bigger than 0 plus 3? Yes, it is. And so that gives you a little bit of help on these guided notes. Hope that helps. Boom! Uh-oh.